Okay, right. Okay, Rhino is a CAD program, very, very useful for many, many applications. Artists use it, architects use it, designers use it, even people who then move into gaming, for example. You could sort of create, I don't know, architectural environments, so on and so forth. What I find very important in people, why people should learn this program, it is also a stepping stone into robotics. I have mentioned that we will get a robotics laboratory at CBA, and Rhino will be the sort of CAD tool to produce drawings and to feed the robot with information. So if you want to go into robotics, Rhinoceros is a very, very good, you know, entry to that type of technology. So, pardon. Now, in this first lesson, I want to just explain how to navigate and what you can do with generally with these. So I'm gonna open a new document. So that's here, Apple N. So usually all the normal shortcuts kind of work here as well. The shortcuts you know from other programs. So Apple C, Apple D, Apple V, or Command V, Command X, and Command C, for copy and paste. So the reason I also told you should get a mouse with a scrolling wheel, because scrolling is, you know, how do you navigate? So basically what you first let's have a look at what we're actually looking at. So this is a program, and we see a green line and a red line. The red line is called the x-axis. The green line is the y-axis, yeah? And I think if we go to, quickly need to change this with the preferences. Oh, is this Rhino 5 here? Hold on. No, this is Rhino 6. Displayed modes. Objects. The grid view shows z-axis here. That's what we want. And I have just added the z-axis, the z-axis. So these green and red lines will be quite important to us, because when we later on today, I will also do a basic explanation of the laser cutter. The laser cutter operates, so now we look at this from the top. This is the x-axis, this is the y-axis. So when we cut an object, and let's say the cursor is the cutting head of a laser cutter, it follows a code according to an x and y coordinate. That can be a line from here, let's say, to here. So hold on. I just want to have one line. So this line has a beginning point and an end point and an angle. So this point has this line has certain data that comes with this line. And this data that makes this line can be sent to a machine that follows that line and does something with it. So for example, this line can be cut by a laser cutter, or it can be cut by a router, yeah, or it can cut by a plasma cutter, yeah. So, but back to the general navigation. When we look at an object, so let's make an object. I'm going to start with a simple box. Hold on. Zoom in. And hold on, I need to organize mine. So we have this box. And I do this again to show you how you actually can move quite easily from one field here to the next. So I cancel this again. So I select my box, the box corner to corner and height. So I go whatever. So this here, the area where I'm operating in, the field I'm operating in, is the view from the top. Yeah, so I create the box, and at the moment we're looking at it from top down. Yeah, so that's the plan view, or view from top. Okay, let's say I want to have an oblong like this, and now I can go into any part of my 4 fields. So at the moment, if I please follow what I do with my cursor. With my cursor, I go now into the front view. Yeah, this is the front view, side view, all the view from perspective. So I can use my cursor in any of these fields and it reacts. Yeah, so for example, I can go into my 3-dimensional view. Let's say, oh, I want to make this quite tall. Yeah, so here, well, this is the top view, then we have the front view, the right view. So this is the front view, the right view, and the view from the top is here. And this is obviously the perspective view. All these 4 views, we can give them different shadings. So in shading, it can sometimes help to orientate. So for example, whenever I activate the field, you see the top left corner is activated, it goes blue. Yeah. So whenever I click on it, this field is activated and I can work in it. But also when you move with the cursor from one field to the next, it gets activated. If you want to be more precise and just work on from one specific point of view, you can click on this top selection area here, or you just double click onto whatever view you want to select. For example, if I want to go to perspective, I double mouse click with a left-hand mouse click, I double click on it. Okay, now when we have this, how do we orientate ourselves? If we want to scale in and out, we use the scrolling wheel of the mouse. So I scroll in and out of this. If I want to rotate, and that's why you need a mouse with a right-hand button, you use the right-hand button. And then you can move this cubus around. Really quite simple. Yeah. So now Rhino has various functions, and this is sort of the functions are sitting within the tool palette. So here to the left we have the tool palette. So this upper section here, and some of you might work with Windows, it's very, very similar. Some of the tools might be displayed on the top, but there's not much difference. The tooling and the symbols are totally the same. So there should be not much of a difference between Rhino for Mac and Rhino for Windows. So when it comes to drawing something, we can draw something as line drawings directly. Yeah, and for that we would use, for example, lines. And under lines, when you see all of these tools have submenus, so you will recognize that all these menus here, including the submenus, offer an awful lot of options. Yeah, so you can do line and you can do polyline, so that continues, and you would right click it to finish it. Yeah, I'm just gonna select and delete everything. So this is how you can draw lines. Yeah. Now with control curves, you want to draw curves, which is much nicer. You can draw curves, and sometimes it's quite useful to work with curves. And again, in curves you have a whole lot of different types of curves, and there you would really need to just practice which curve is useful. sometimes, for example, if you have a picture, let's say you want to have a picture and you want to make a cutout. Let's say you have a picture of a cute duck. You want to make a laser cut from it. You can import the picture onto Rhino, and then you could use this tool to kind of follow the picture of the duck and export that line to a laser cutter and make a laser cut of a duck. Yeah. So it's kind of, you know, you have that option in Adobe Illustrator, but this is far easier here and it's much more elegant. Right. Then you have obviously squares or rectangles. If you press the Shift button, you will not create an oblong, but a proper square. And then we come to surfaces. So here we have surfaces with 3 or 4 corners. So this means when you draw a surface, you see this cross appearing. And when we actually use a different type of render, let's say, let's render this one here. Let's shade it. You see here in the perspective mode, we have, if we do this with, you know, this shape, whatever, you see here we have a line, and here this is a surface, yeah. So this will be useful later on at later stages, but there's a distinct difference. However, you can very easily convert a surface area into a line drawing with Rhino. We will probably at some stage come to that as well. And what, for example, you can also sort of play with. So here, looking at the top view, we're looking at this from the top. If we activate this and we go to the front view, so we are looking at the surface now, not from the top, but here from the front view, we can grab onto the blue arrow. The blue arrow is the Z direction, so the up and down direction. Blue is Z, always up and down. And if you pull this up, you can see here in the perspective mode, it seems to kind of lift off the ground. And if we do this now as rendered, well, not this one here, we want this one rendered. Oh, I need to put some lights in here in order to kind of, hold on, can we? Hold on. Now we first need to, for example, here, let's do a surface here. And we do that wireframes, but this one here. And here now, when we render this, we can actually see that this surface seems to be kind of off the ground. Yeah, we can actually apply lights and stuff later on for rendering. So Rhino also, when you, for example, if you design something, you can render it quite nicely. You can give these materials, so like wood or stone, and you can export it, and they look quite sort of lifelike. So if you want to, I don't know, design a bench or something in wood, and you have a client meeting in Rhino, you could actually render this to quite a high degree that it almost looks like it has been produced already. Yeah. So a lot of CAD programs have these options now that you can design something that is lifelike. The difference, for example, from Rhino to the Adobe systems, in Adobe you would always work flat, whereas here you can literally kind of move around an object, and you can also build an object in a space. Yeah? Okay, but rendering is something we probably will not deal with here because it's not really relevant. But you know, for those who are interested in Rhino, it's certainly something you might want to explore at some point. So we have seen, so here we, again, going back, we have line drawings, we've got surface drawings, and here we can, this is a tool where we actually manipulate these surfaces, not something we have to kind of deal with right now. Then this is a tool where we can actually create three-dimensional objects such as box or cylinders or spheres, you know, ellipsoids, parallel cones, whatever, you name it. Yeah. So I really entice you to play around with these things in the next few days, just to familiarize yourself with these three basic elements. And anything down here is actually our tools, what to do with whatever you draw and to manipulate it. Yeah. So anything down here, we will come to that later on. But you will mainly work with the three-dimensional objects and lines and so on and so forth. So, is this so far all clear? So again, to revisit, in Rhino you have 4 fields. You can also change the setting that you, for example, look at an object from the front and the back, but this is the sort of classic view that you look at an object when you design an object. You look at it from the top, from the front, from the right, and then an isometric view or the perspective view where you see this thing in sort of three-dimensional, sort of in a three-dimensional space. So go back to a wireframe. Right. So any questions so far? What we also need is box edit activation. So whenever we have an object, and if this doesn't appear in your panel's edit box, you need to type it into the command. So basically, that's another thing. Quickly recap. Organization in Rhino is the top view, the front view, the right view, and the perspective view. The tools are lines, surfaces, and volumes. And these are the tools to manipulate all of the above. Then we have a command box. Those who work with Windows, the command box sits on top. Yeah, it's exactly the same, but those working with Windows, the command box is a long box, and whenever you type on it, it also kind of shows you details about what you do. There are a few commands you will have to learn, and I will write them down in succession. So that doesn't mean you need to learn coding, but they're sort of quite intuitive. For example, if I want to move, okay, let's say I have a box and let's have another box. Oh, now let's make it a little more crazy. Let's do a cylinder. Okay, I want to make a cylinder. I'm going to put the cylinder there. Let's put it that way. Okay, so here we've got the cylinder. Yeah, so I've got the cylinder and I've got the box. But I want to have the cylinder, let's say, what you can do in order to move objects, you can grab the arrows. So if you want to move the object into the Y direction, you grab the green arrow and pull it. You first need to activate the object you want to move. Yeah. So and then you can pull it with the arrow. And you can move it, but you can't move it so downwards. Yeah. You can also turn it, and you see this little curve here. If you click onto it, you can actually move it and change the angle of it. Yeah, it's quite useful. And if you want to be really precise, you can also type the angle grade in. So let's say 45, and it turns forward at a 45 degree. Yeah. Now, if you want to place this one at a very specific point, you could sort of start toggling it with the arrow somehow to the spot you wanted. But very often, it is quite imprecise. You think, oh yeah, this fits. But if you zoom in, you know, you can't really kind of move it, you know. So for this, we use commands. For the more precise stuff, we use commands. For example, move. And whenever you put a hint in, you don't have to type the whole thing. It then appears in your command bracket here on the top as a suggestion. For example, move. So you go move. So now it asks you point from to move from. Let's say I want to move it from. Hold on. I want to move it from there exactly to that point. Yeah. So this is how you move objects or curves or lines. You know, if you have just a line, let's draw a line. Okay. So when you look at it, where is this line now? I activate the line, or the line is obviously there. You can move the line there, but also you can type in the command move. And you press enter, and then you can move it, let's say, from here to this corner. Again, we make use of our right-hand button. Now I click the right-hand button, the right button mouse. If I click on the right button mouse, you get everything I have done so far. For example, selecting a box, the box corner, the border, all those things. I think the last 15 or 20 commands will appear on a list when you right-click your right mouse button. You will use this quite a lot because very often what we do is we just do repetitive things. Yeah. So, for example, if you want to move again, you just right-click. For example, I want to move something. Okay, let's move. It asks, what do you want to move? Select objects to move. Let's say I want to move this. You press done. You can also press enter. Okay, I want to move it from here to this corner. Yeah. And when we look at the perspective view, when we go into rendered, so we have all these sort of objects and lines sort of lined up in space, but I want them all on the ground floor. So how can I get them all to the ground floor? Yeah, so the ground floor would be exactly here where this red line is. I can select it and I can sort of individually drag them, or I can go to, and this is where this is the box edit. So this is an edit field, which we will use quite a lot. And here you can actually type in what you want with this. So for example, I want the Z position into the 0. And I probably have to do that with every individual object. So Z means I bring it all down to the 0 position. And this line as well. I go to this field, I type in where I want it. So 0 means on the ground floor. So basically that's where you stand on, you know. So this is the ground floor and I apply it here, press apply. So at the moment I have all my objects lined up on the ground floor. Imagine everything falls down on your desk. So this is your drawing desk, the ground floor. And then, you know, if you want to build something up, you can move them in the Z direction upwards. So I think I have mentioned it already. Where you downloaded a Rhino 6, there are a number of tutorials, and I strongly recommend you to go through all those tutorials just to read. I think, for example, it shows you how to make a water glass and render it, you know. I think you should all do that at some point in the next week, really. So just play around with objects. If it doesn't work out, you can always delete it and start from scratch. But you really need to familiarize yourself with this program, because I will ask you not only to create this box, but also you need to, whatever you produce later, physically in the workshop, you need to produce a drawing first in Rhino. We have another late arrival. Carrie, have you lost us, or are you a new arrival?
My computer just shut down.
Okay.
So,
make sure all your batteries are, you know, I think when you work with Rhino, you also have to make sure that, you know, plug it in. This is a program that needs a lot of oomph. And I hope you have all a half decent computer at home where you can actually properly work with. Okay, so again, I will repeat things over and over again. In Rhino, we have the view from the top, the view from the front, the view from the side, and the isometric view or the perspective view. When we right-click the mouse, we can move stuff around, and scrolling, when we scroll the wheel, we can zoom in and out of objects. So this is how we actually navigate around. Yeah, and you can, whenever you move your cursor to another field, you can scroll. And obviously, when you right-click in a view such as top, you right-click. Hold on. No, I don't. If you move, you go in and you right-click, you see the hand appearing where you can actually drag things around into the right perspective. And then you can scroll in and out, yeah? Our tools sections are here, the command section is here, and with the commands, you will probably have to, you will learn not more than 10 commands, and they are very simple, such as move, or what else do I, there's a few standard commands I use generally, I can't really think of them, but things like move or probably duplicate and stuff. But anyway, there's a lot of shortcuts that are quite useful, and I will create a list from that. Okay, now what we want to do is, though, in this session, I want to tell you how to actually make a finger locking box. And now let's go back to the Excel sheet. So these are, obviously we need a few more. We will fill these ones out towards the end of this lesson. You all will need to produce a box, and you all will have to produce a different box, because I know you will become lazy and just, you know, so all these boxes are different. In whatever box you produce, I will measure it later on, and I will count the fingers. Yeah, but let's take probably the most difficult one, the 80 and 80. I'll do this. Okay. Okay, I'm gonna make this one. So we have 80 by 80 by 100. So that means it's 80, the depth, the length, the width is 80 by 80, the height is 100, and it has 6 fingers. Yeah. So what does that mean? So the box will be 80 by 80, and this is at the moment a 2-finger box. I will make one with, what is it? How many? What's my assignment? 6 fingers. So I will have to make 6 fingers rather than 2. So 3 is the outer, but so basically the fingers that are inside. So if you, whatever, whatever Eric or so needs to get the assignment to do this box 130 by 100 by 100, you will have to do 5 fingers. So you will need to do not 2 but 5 fingers in between. How you design this, we do that right now. So okay, let's finish this. I'm going to start a new file. Okay. We could have used this one as well, but we can throw this away. Okay. Now, right. So what I need to write it down. It was 80 by 80 by 100, 80 by 80 by 100 with 6 fingers. Okay. Right. How do we start? Okay. I design it basically, we will work with a 3mm plywood. So imagine, yeah, we have a piece of board, 3mm, we put that in the laser cutter, we want to cut it. So we need to tell the laser cutter what to cut that we can build this box. Once we cut it, the gluing will probably take 5 minutes and then it's done. The real work happens here. The machine will do an awful lot. So I will start this with a ground plate. So I will go to box. So we go select box, corner, corner, and height. Yeah. And I will just follow that. You switch on auto. So that means you do not do any diagonals. At the moment, we're just operating all lines in an orthographical sort of direction, either in X, Y, or Z. Yeah. And okay, so I select a box, corner to corner and height. And now what you can do is you just type in the number. So we are talking millimeters, so we type 80. So that's the corner length. Yeah. So the first thing it selects is the x-axis is 80mm. The width, so the y-axis is also 80, and I just type it in. You can do that with 3 fingers. Yeah, you don't have to. You basically just click the starting point and then you start typing. So I type in 80 and press enter. And when you look, so you already have your ground plate. Now we want to go into how high is it? We know we are cutting a 3mm thick plywood. So the height here, as suggested in this box here on the corner, how high is your cutting material? It's 3. And then we press enter. And now, when you look at the isometric, at the perspective view, we have our ground plate. Yeah. Now, if something goes wrong, let's say you end up with this, and even higher. Yeah, and what you see is you can actually change the sizes here by pulling these little squares at the end. Yeah, so this is how you can actually change shapes, and you can do this in whatever field code, in the Z direction here, in the X direction here. But basically, imagine you have made a mess of your ground plate and you need 80 by 80 by 3. Yeah. You go to box edit. So, and at the moment, this is basically the size of your box. Yeah. Let's say we change it and then you see how it changes. Yeah. So here in box edit, so this gives you all the data of this box. Yeah. And say, okay, you can also just type it in here. Yeah, so you could go X is 80, Y is 80, and the thickness in Z direction is 3. And you just apply it, and you have your box. Yeah, and the problem is now it's not really relevant here, but you also want it to sit on the ground plate, that it falls on your ground plate. So the position, always good to kind of position things in this corner here, into this corner. So you go 0, 0, 0. So to start with your starting object in the 0 location. Yeah. So this is a very useful, it might be a little bit nerdy and computer geeky, but this is a very useful, when you want to work precisely with measurements, use this field where you can actually type in your dimensions properly. Yeah. So now you can actually see your ground plate has sunken to your ground floor. Yeah. So we have that nicely located. Beautiful. Okay, now I need this thing 100 millimeter high. So this is probably 40, so it will be about this big. Yeah. Right. So how do we do walls? There are many ways to do walls, but I want you to kind of start building things as if you kind of cut real material. So we are always operating with a 3 millimeter plywood. Yeah. Okay, what would you do? Okay, you have obviously walls. You have a wall here and here and here and here. But so you go and select a box, corner to corner height, and you zoom in on your plate here. Yeah? And you see that your cursor gets activated. It kind of is like a magnetic corner. Yeah, it snaps onto that corner. The snapping, that's something we can sort of discuss later on. You can also decide what you want to snap it on. So usually it comes with areas that are sort of very common, like it snaps to an end or a point or a midpoint. What does that mean? At the moment here, you get that little sign saying end. It snaps to the end point. If you move your cursor to the middle, oh, look, it snaps to the midpoint. So that's kind of quite useful. For example, so I'm going to go and snap it at the end point and drag it. And I snap it to this end point. Click onto it. And I drag it. So you could drag it here, which I did falsely. And then let's do a complete cock-up and let's make a sort of a weird box. So, okay, this didn't work out. You'll say, you know, your wall is this giant thing here at the end. Yeah, it's not a problem. We can activate it. So obviously, in your X direction, it already has the right measurement. So X is 80. That looks good. The Y direction, so it's the green arrow. This thing is almost 30 millimeter thick, so a thick board. We only have a 3 millimeter plywood board, so we just type in 3. And then it shows you, oh, this is how it will look like, yeah? And in the Z direction, we want it 100 millimeter tall. And then you go apply, yeah? So now we've got this board here sort of sticking right in the middle. So you could sort of start again using your arrow and moving it kind of into the right direction, but you never really get it exactly precise, yeah? What you want to do is, you again go to your move command. You want to move it, and here it's actually quite useful to go to your 3-dimensional perspective. You want it exactly, and I want to have only the perspective view now in order to kind of get this right. You can sort of see this is slightly overlapping. This is no good. You want it from here to there. And when it snaps, it says end intersection, then you click onto it. And now we have our first board almost in the right location. But we leave it like this. So we have one wall. Okay. Now let's go. For those who are sort of familiar with these things and think, oh, if we kind of build the rest of the walls, this thing is then not 100 millimeter high, it's 103 because the base is 3 millimeters. So we have this one, which is 100 millimeter tall, and we've got this is 3 millimeter tall. So it's 103. If you get a job to build a box exactly 100 millimeter tall, we will move this one upwards. We'll come to that later on. But let's first do all the walls. And the easiest way to do this, we can, for example, mirror something. If we type in mirror, so we go onto our command field and we press, you see mirror appears. Okay, we already have activated this and we would just want to mirror it here. You might kind of know this from some Adobe programs, I'm not quite sure, but this is a very useful. So literally we just mirror, you basically just have to design one and we mirror it onto the other side, yeah? What we also can do is we can just copy and paste it. So we can activate it, whenever it's activated is yellow. We just copy, so Command C, Command V. I have Command V it, so I have pasted in, and it always pastes exactly in the location you have copied it. So if you click on this one and it asks you extrusion, we have two extrusions here. We have extrusion 1 and extrusion 2. So obviously we have two of the same things. You can click onto any and drag it down, yeah? So you can either copy it or mirror it. What I would do is always copy it, mirror it, because it's much easier. So here I right click on my mouse, I go mirror, and I go here to midpoint, so I know exactly the ground plane. If I mirror this on the mirror point, on the midpoint, I have this thing exactly at the right spot where I want it. Nice and snug there, right in this corner, yeah? Because I selected the midpoint of the ground plate to mirror this plate. Okay, so we've got already two sides. Now, let's go on to the other. What we're going to do is here, you think, I'm just going to do this here in between, but that's not the way to do it because we want these things to intersect. So all the plates need to be the full 80 mil size. Yeah, you will understand it when you actually build it. So here again, we go on to this. And here I would just basically type in the X length, and that's 3. And then I go down here and I click that onto the end. Yeah, so I have my side bit here. And quick look at the side view. Oh, look, we selected that one here, but that's not a problem. I would actually, what I would do now is, if these sort of stack up, don't worry. It's really far easier, for example, now to go back to the position, and we want this to position at 0 point. Yeah, and here, hang on, how tall is this one here? Oh, this is only 80. We don't want this. We want it 100 by 100. The size is 100. Okay, right. So we have the side wall here, and at the moment you see the side wall is all the way down. We will move these ones later on down to the 0 position as well. But again, we now mirror this onto the other side to complete the 4 walls. Mirror. We go to the midpoint and basically just mirror it onto the other side. So now we have these two sides. They are based on the 0 point on the ground plate. These ones still stick a little bit out. So I select those by holding the shift button, and I put them in the Z direction onto the 0 position. Apply. So you see, they're all down here now. Yeah. So this is a box. You can also go to the view. It's rendered. So we have quite a nice box. The problem is, when we look at the wireframe view, we now need to kind of create the teeth. Those teeth, these interlocking teeth. So there are various ways to do it. How do I do it? let's start with a view from the front. So this is the view from the front here. And we want now to get this sort of ziggy-zaggy view. I think I have shown you this in the PowerPoint presentation last week. Just to give you again, current wood. Let's open this one quickly. Here, not this one, this one. So basically, this is what you're going to build. Slightly more sophisticated than this, but we need to kind of design these tees. So let me go into view. So basically what we want is this ziggy-zaggy look here on the bottom as well as on the side. And I have the task to make 6 fingers. Some of you have probably less. Okay, so I want to have these fingers sort of cut in there. So the way you go about it, you go again to box, quarter to quarter in height. And I zoom in, so I gotta click onto it. I'm gonna make this, make a little thing and make it 3D. So if we click onto this and we go onto our view, you see that I made a little box here. Yeah. So we look at this from here at the moment. And if you look at this, it sits there. But that's absolutely fine because we continue this. So we have a look at our, we need 6. And I think we make it slightly shorter. So this is at the moment 12 millimeters long. Let's make it 8. I could sort of calculate now the exact, but I'm just kind of guessing at the moment. So at the moment, I have a little box that is 8 millimeter high, 8 by 3 by 3, yeah? And I need 6 of those. And then you go, you could sort of copy and paste, copy and paste, copy and paste, but that's far too complicated. You can use the command array. Okay. So, and in the number of direction, in X direction, you literally just want to have 1, that's fine. So you press done. In the Y direction, you also press 1, but in the Z direction, you press 6, done. And now you need to kind of Z for spacing for the first reference. Is that here? And no, we don't want that. I need to do this again. So I want to have it in, hold on, I want to have in this direction. 1, yes, done. In the Y direction, 1, but in the Z direction, 6, done. So why doesn't it work here? Spacing should be here. And now I'm not understanding why this is going in this direction. Hold on, let's do that again. X, Y, and then Z, 6. You have to click on the top. I don't quite understand why that is, but there you go. And now we zoom in onto the front view, and now you can actually distribute these 6. And I sort of kind of realized now that this is probably 1, 2, 3, 4, 5, 6. That looks kind of all right. And then we press done. So you need to kind of play a little bit with the array button. So you need to kind of, when you array, you need to activate the top view, but you need 6 items in the Z direction. Yeah, and you need to kind of figure out how to do the array. So what I do now, I activate all of them, and you can sort of make a little selection that's just like in Photoshop. No, I just want to have this one here. And I group them. That's also a command you need a lot. So you type in group. I make a group of these ones. So this is now a group. I can move them around as a group, which is very useful. Yeah. And I would probably now move them into this corner. So again, I use the move here. I need the move. I need to put the aircon on. So select the move tool, and you go from this corner into this corner. And when you look at this in your perspective view, you see these parts embedded within here. But I'm just seeing so at the moment we have, that doesn't mean that that what you now need to physically do, you need to extract pieces. So in order to take pieces out, yeah, so you need to kind of extract pieces from A and B. So when we have this one and we want this to remain, we need to take these pieces out. So how do we do that? We go to a Boolean split. So Boolean is something where we organize or cut through three-dimensional objects. So what we got to do is we do a Boolean split. Yeah. So and then we will ask, Rhino will ask us, select a surface or polysurface to split. We select this board here. And then we need to select the cutting surface or polysurface we want to use. We use not this one. No, I want to have that one. No, we want to have that one. I want to have, so you just select these ones. So what we do now is when we click onto this one, you see we have developed this sort of jagged outline here on this side. Now, how does this look here? This is still the same. But let's first finish this side. So we need that jagged outline exactly on this other side as well. So how do we do that? It's not complicated. We select our little cubes there again here. And we go to the front view. In the front view, we use a command we have already familiarized ourselves. We mirror those little cubes and transport them over to the other side. So we right-click our mouse, and we should find mirror here. We click on the mirror, and we just mirror them over. Yeah, and we do now exactly the same. We do a Boolean split. Now we select the surface or polysurface to split. It's this board here. Very useful to kind of keep the perspective window active, because then you see, yes, it's this one. We select this one. So, and then we will be asked to select the surface of polar surfaces split. That's this one. We press done. So select the cutting tools. We want to select those little cubes that are sitting in here. So we go to our top view and select them. No, not this one. We have to start this again. Boolean split. This one. Done. And we want to take this one, this one, this one, this one. No, that one, and that one, and that one. No, that one. We press done. And now when we click onto this wall, we have already one side almost finished. So that's pretty cool. And now, the next step you should do is I would actually mirror this side over back onto the other side because this one is already pretty finished. So I might just gonna take this one and mirror it over. So I'm gonna destroy this. I delete this one. I select this wall and just mirror it back onto the other side. Right click mouse, mirror, and swap it back there. So bingo, you already have two sides with your interlocks here. Now, our problem is still this one here. When you look at it, this is still a proper square. So that's not a problem, because what we're going to do now is we do also a Boolean split. And what do we want to split? We want to split this side wall that doesn't have the intersections here. This is the surface of polysurfaces to split from. And what do you want to use as a cutting tool? So select cutting surface of polysurfaces. So we use this one and this one. And bingo, we have our interlocking sides. Yeah? So at this point, it's perhaps quite useful to select these little cubes. They're not useful to us anymore. We just delete them. So you select them like, not this one. We want to have these ones here. No. Well done. So at the moment, what we are left with is these walls with the teeth on the side. Now, we want to make a nice box. So the floor, I think what would be nice and would look nice if the floor is slightly suspended from underneath. So I'd say, let's move it upwards in the Z position. That's 5 millimeter. And you can see the bottom floor is kind of moving up a little bit. So that kind of makes a nicer box, you know, when it sort of stands. Yeah. Now, obviously, we need to do exactly the same here as we have done with the walls. So we also need to kind of do it like an intersection here. And we make it perhaps a little bit easier here. So perhaps we're just going to make 1 or 2 intersections. That's good enough. Again, we go to our box, corner to corner height. And I would make this probably 25 millimeter wide. And the width, 3. And the height, also 3. And we want to move it, obviously, into this corner here. says no. And you can basically move it around here. And you can see this is our inner floorboard. So you can select this, right click, move. And we want it obviously from there, there. I usually would do this via a view from the top and the view from the front. It's a little bit more precise. This, because when you have a lot of lines here, this can get increasingly confusing. Yeah. So we've got one thing here, but obviously, basically, we want to have sort of like a knob sticking out there. Yeah. So again, we use our mirror function, and we mirror that here. And I think we can actually do quite a nice job. Sometimes it's kind of quite annoying, you know, when you actually want to select this one, these little parts. When you have things that are kind of finished and you at the moment don't want to touch them, yeah. What I tend to do is I select these ones, hold Shift down, and you can lock them. You also type in Command Lock. And then you see that kind of turn gray. And the great thing is, you realize, oh, we've got some of these little corners left, these little things. And now you can actually literally select these things without selecting anything else and delete them. So that's actually a very, very useful tool. If you want to just see what you have done, but you do not want to touch it. You know, sometimes you're done with it and you do not want to touch it, and by accident you do something, just lock them for now. Yeah. And to unlock, you just type unlock. So if you type in unlock, everything unlocks again. Yeah. But let's lock them up. I hold my Shift key down, right-hand mouse click, lock. Yeah. So we have the nice and gray. And now we can actually work properly here. So we've got our ground plate here. We've got our little strips here, the 3x3 by 25. So I select this one and this one. No, not this one, this one. We want this one and this one. And so that's on the side bit. And I also mirror it. And the nice thing is when you have locked things, you can still, they still snap to their mirror, to their midsection, for example. Yeah. So what I also want is a little sort of sticky outy thing here. So what I do is I copy these ones here. So I copy them, Command copy, and Command paste it. So I have now 2 times these little square brackets here. And there, no, I don't want that. I want them 90. So I click and I turn them in 90 degrees. And I move them from there to here. Oh, they stick on the top now. Look, we don't want that. We want them. We want you guys down here. So I repeat move. I want them from there. Let's get this over to away. Look, where are we? Hello, cursor. I want to stick them down here. Yeah. And what we're going to do is we again mirror them to the other side. Press Shift to kind of keep them. So we have these little sticks lining up quite nicely around this ground plate. And you should now get the drift. We do again Boolean split. What do we want to split from what? So select the surface of polysurface to split. So we want to split the ground plate. Yeah. Done. And now select the cutting surface of polysurfaces we want to use as a cutting tool. It's these bits here. You just individually click on them. Yeah, that extrusion. And then we're done. Okay. And now, what we want to do, obviously, we want to get rid of these little brackets. So we destroy them, we delete them. We want to get rid of them. Now, you realize that we have those side parts and they need to kind of stick in here. So basically these brackets need to kind of stick into the side parts. How we do that? We first need to unlock everything. So we press unlock. And now we do again a Boolean split, and perhaps we can do this in the full view. So what we want is this to penetrate the side walls, this piece that sort of sticks out. So again, we go Boolean split, select the surface of polysurface split. So we want to have the 4 walls. We press done. And now we select the cutting surface, that's the ground floor. Okay. Now let's have a look how this actually looks in a shaded view. Yeah. So here now you can see the ground floor is penetrating the side parts. And for those who are a little bit more advanced, you know, you can also, for example, make little legs here. You can move this up. Then also, you know, you can sort of also experiment. If you move this one up, let's say to this level, you can just kind of create little legs. You could do that with little boxes, for example. So you could create a little box underneath and subtract the whole lot from it, for example. But so this is basically what all of you need to produce with the instructions I have given. So the problem is this is still not a cutting file. Yeah. So how do we get this into a cutting file? And Rhino has a beautiful a tool to produce the cutting files we need for the laser cutter. And that is a command that says make 2D. So this command is make 2D. We select everything. And we will start selecting. At the moment, no, let's do it differently. Let's say, okay, we need the front view. Okay, this is a plate, obviously. This plate, we need this, but this is a polysurface, so this is a 3-dimensional object. We just want it as a line drawing for the laser cutter, because the laser cutter doesn't want all these other lines. The laser cutter literally just needs the outline of this. So if we go again to our command make 2D, select your object to draw, we just click onto it, this polysurface, and we press done. And we just click tangent edges. And we select group output. That's quite useful. So this is the front view. And we project it on the C-plane. No, onto the view. Hold on, apply. So this is our top view, and now we see this bit here. And we also realize we have some mistakes here. We need to ungroup this. we want to get rid of this one here. Is somebody texting me via the? No. So this is what we want. I group this again now. So this is one wall. So this is the top and the front. So this is the front view. Now we go to the right view. We do the same. We make 2D. We select the object we want to make in. It must be a polysurface. It's this one here. And let's not group output it. We go, and your projections will always go to the ground view. And again, sometimes you need to re-edit. For example, what you don't want is these bits here. Because every line you see, the laser cutter will cut. So the laser cutter will cut through, basically will cut your fingers off. So you need to kind of remove these ones. That you just click on them. And this is basically the area where your ground plate will penetrate the side. So, but you want to get rid of that. Otherwise, you would just cut the bottom off. This is why I need to look at all of your technical drawings. But please keep in mind, everything you draw is cut. So everything you draw is cut. That means this finger will be cut off. Yeah. So in order to figure out whether these two pieces fit together, you can always make. So the next thing is you want to activate, you want to group this. So this is one area. So you activate the whole area and you type in the command group. Yeah. So this is a group. I have already turned this into a group. So this is a group. So this is the front, this is the side. Now let's see whether I go move. Do we have the move here? So this space should fit in neatly here. Voila. Yeah. So this fits in. So this is basically the two side views. You can see they match. Yeah. Because they will go like this. Yeah. So they need to kind of, basically this is just like a book folded up, this box folded up. Yeah. Now we move this a little bit on the side. At the moment we only have these two sides, but we obviously have four sides. So we need to do front and two sides. So we need to, you can either mirror it or copy and paste it. I just copy and paste it. Okay, so I have all my four sides. Now what we want to do is also, we want this ground plate, this one here, yeah? But we don't want to have these lines. So what we can do is we go again to our make 2D, apply. And oh, look here, it didn't make any mistakes. So this is our ground plate. And this is exactly what we need. This is all we need in order to do a box in our laser cutter. Now, this was a lot of information. I'm well aware of it, but we will, I all want you to do this exercise. Just follow what I have done. And next week, I can correct your drawings. But once you get going, it's actually not that complicated. It looks perhaps a little bit like a humongous mountain, but it's actually not. This is a sort of a standard. I mean, it's quite complex in terms of the thinking, but this should be all manageable for you. Now,